Good morning, good afternoon, and good evening. Thank you to everyone for taking the time out of your busy day to join us for a very special web event. I'd now like to pass the floor to our presenter today, Robert Ferrulo, who's a Senior Technical Marketing Engineer with Mojo Networks. Robert comes to Mojo with over 20 years of experience in the networking industry and nearly a decade in Wi-Fi, along with 15 years of 15 years of experience in performance testing. Today, Robert's going to kick off the second in a three-part series around campus networking. In this session, Robert will be taking you through the deployment best practices for Campus 802.11ac Wave 2.
All right. Thank you very much, Erica, and welcome all. We got a lot to get through, so we're going to go at a pretty fast clip here, and we'll start with the agenda. So just want to take a quick look at what we talked about in session one. So we'll have one slide on that. And then we'll talk about site readiness. Really, it's just it'll be a checklist of things just to make sure that we thought about and have taken care of before we start the deployment. And then we'll go through some deployment best practices for wireless LAN, then LAN, and AP channel deployment, and then finally wrapping it up with network services. And let's see. Now, this series, the three-part series, as Eric mentioned, the first one was channel capacity planning best practices for Wave 2, and this one is about deployment best practices. We're going to have another one, I believe it's next week, and that is going to be network management best practices, where we're going to look at monitoring and really optimizing and troubleshooting your network. Because it's all an iterative process. We have to constantly be trying to improve performance, and that's a ongoing thing, of course, right? Iterative. All right, session one recap. So that was channel capacity planning for WLAN Wave 2. And we started it, and by the way, that if you missed that session is available. You can get access to that through our website. That we started out with a challenge, and the challenge for me has always been mainly about making sure that all applications work on all devices all the time, everywhere, and that's keeping all devices working all the time. That means we get our nights and weekends. Nobody wants to spend nights and weekends solving problems. So that's something that we want to be able to solve without spending too much time on the job. And so we talked about designing wireless LANs to meet use cases last session, and we presented a simple way of doing that back of the napkin calculations. We introduced the Mojo C120, and we reviewed the multi-user MIMO, the benefits, and so on. And then we talked a little bit about Mojo Planner and AP placement and channel planning. And finally, we went through campus use case. So again, if you haven't seen that webinar, then I welcome you to go visit that, because I think you'll find it very helpful. So there are a lot of things we're not going to cover today. We're assuming that we've already figured out, what type of, how many APs we need and so on and so forth. We will touch a little bit on some of the same things we talked about last week, but only for continuity in this session. Okay, site readiness. This is a checklist that we put together. And the reason why is because anybody that's been in this business long enough, we know there have been truck rolls, there have been flights, people have showed up on site ready to do the deployment. And there are some things that were not considered, and you end up wasting time. Sometimes you just have to get back on the plane and go home because you're not ready to do the deployment. Hopefully that doesn't happen too often, but it does happen. So this is really just a checklist. This checklist, you can find it in the Campus Deployment Guide. The Campus Deployment Guide is going to be available to all of you, and it's a comprehensive guide. It's almost 80 pages long, and a lot of the content that I'm sharing will last session, and for all three parts of the series, you can find it in the Deployment Guide, Campus Deployment Guide Best Practices. So I won't go through this whole list today, but I'll just talk about a couple of things. One of the things is for the verification preparation. If you're doing the deployment and you want to make sure, there should be some kind of a verification process where you have a verification test plan, and that would include using the actual clients, ideally, that the customer or the network is going to have present, and then some kind of acceptance test plan where you're testing the various clients, you're testing roaming, you're testing the applications that are going to run on the client, and you're testing in areas that where there have been problems in the past, certainly. One of the things you may not be able to do so conveniently is to test worst case scenario where you have high density. That may require, actual whenever that high density happens in the real, with real users. But that's something that you should consider too. At least having the plan to monitor the performance of the network when the high density actually occurs with real users. Let's see. The other one I want to mention, firewall rules. Now, I put the ports that are required to be open for our solution, but it's going to vary from vendor to vendor. For cloud vendors like ourselves, we do have some ports that we have need to have open so that our APs can reach the cloud service for management purposes and monitoring. All right. Let's see. Now we'll jump into deployment best practices. One of the things that I like to talk about, I always talk about, it would be channel width selection, because that's one of the places where you have to start, right? Because you have to kind of decide on which channel width you're going to use. We talked about this last session when we did channel capacity planning. Just thought I'd mention it again here, and also highlight that when you're going from 11N to 11AC, you get the biggest bang for your buck with 80 megahertz channels. Now, you may not require 80 megahertz channels anywhere. You may not require them everywhere. But just to point that out, that's where you're going to get the greater capacity. Not everyone upgrades to 11AC because they need more capacity, but most venues are being need to upgrade to 11AC because the capacity is an issue. I would say, at least in parts of the deployment, maybe not everywhere. But there are a lot of factors to consider, and I list them there. And again, this is more to like what we talked about in the last session, so I won't go into it too deeply, but you have it. And you do need to consider many, many things when considering which channel width. So we codified it a little bit here with this next slide, where we have the different use cases listed on the left-hand side there. And let me just give you a little bit of the nomenclature. So with the single AP, LD, LT, that stands for low density, low throughput. And then the HD, the one below it, high density, low throughput, and then low density, high throughput, high density, high throughput. And we say single AP and multi AP because there are remote sites, even in campus deployments, where you could have one or maybe two APs or something like that. So it wouldn't be a multi AP deployment really. It would just be just a small number of users. And we just say that, if it's a low density, low throughput, for instance, 40 megahertz, you could use, 80 megahertz, but not needed necessarily because it's a low throughput, right? It's low density, low throughput. You really don't need the capacity. High density, low throughput, again, you could use 40. You could even use 20. It depends on how high, density it is. But no, you could use, I'd say 40, excuse me. I would stick with 40 with that one. And then if you have like a single AP with low density, high throughput, you could certainly use 80 megahertz, but that would only be useful if you have local content, right? And you may not. If it's a satellite office, if there's, there are no servers, there's no video servers there, or other servers that would require high throughput, then, you really probably wouldn't need the 80 megahertz unless you had high capacity internet access, which is becoming more, common with Google Fiber and so on. Where even if you had a single AP out there, but if you had very high throughput, say a gig, fiber uplink, then you could benefit from using 80 megahertz if you want to try to fill up as much of the gig pipe as you can, and so on. So moving on to the multi-AP, we have some where you have no DFS channels and then some with DFS channels. And so the DFS channels, they're probably not ever going to be in a situation where they're all unavailable, but you may have as a policy where you don't want to use DFS channels because you have a lot of clients that don't support DFS channels, or you found that your network's more unstable if you use DFS channels. So there we're recommending, for most of those type of deployments, whether they're low density or high density, high throughput or low throughput, to use 40 megahertz channels. Now there are exceptions. There are some regions there that have a lot of channels that are not DFS. And if you're lucky enough to live in one of those regions or doing a deployment in one of those regions, then you can consider using 80 megahertz because you'll have the capacity. You'll be able to have enough unique channels without reusing channels so that you can design a nice network without a lot of co-channel interference. And then finally, if you have DFS channels available, recommending using 80 megahertz. In most cases now, you could, if it's a very high density location, like a stadium, right? Then we would not recommend using DFS 80 megahertz channels there. For a very high density, that's the last line down there. So for stadiums and even arenas, for college arenas, indoor like basketball and so on, then you would recommend going with 20 or 40 or 20 megahertz channels. So just kind of a guidance there in terms of helping determine which type of channel which you're going to use. Now, as far as how you configure the channels, or how your auto channel will configure the channels, if you're going to use 80 megahertz channels, even if you're using 40, you want to statically configure staggered channels, or you will rely on your auto channel to do that for you. And so the reason why we recommend this is because if you have, say, like an 80 megahertz channel from channel 36 to 40, which includes 40 and 44 and 48, and you have two APs adjacent to one another, they could share that same 80 megahertz channel, and they could share it in a way that is less of a problem and less CCI, co-channel interference, if you stagger the channel. So AP1, the primary channel, would use channel 36, and AP2 would use channel 48. That way, if both of the APs needed to transmit simultaneously, right, with dynamic channel width, they could each just use 40 megahertz. And if opportunistically, AP1 or AP2 could use the whole 80 megahertz, that's if the other AP doesn't have any packets to transmit at that particular time. So that's one of the nice things about 11AC with the dynamic channel width. And so a lot of most APs support that. I think some of the APs early on, some of the Wave 1 APs that were out there early on, did not support dynamic channel width. So this would not have been a good strategy for them, deployment strategy for them. But our APs do support dynamic channel width, so you could not worry about having the two APs back off and just wait till they get the whole channel. That's not going to be a problem. All right. So this next slide really speaks to wanting to keep the cells small effectively. So we talk about removing the supported data rates, and that would be the data rates that the clients can connect at the minimum dates that the clients connect. And there's also another setting that you'd want to do, which would be the the min data rate that you'd want to send out your broadcast, multicast traffic, and for that matter, unicast traffic. So if you remove these lower data rates, the data rates that the clients can connect that, and then also the data rates for that traffic can be transmitted, you effectively can shrink your cell, and shrinking the cell gives you the ability to reuse that channel. One of the things it does, it gives you the ability to reuse that channel sooner. And then the other thing it does is that it makes the cell more efficient because you're not going to be using lower data rates. So it's a way to improve the overall capacity of a cell, and then also ultimately the overall capacity of a network by being able to reuse cells again. And the Wi-Fi spectrum that's the of course, even with DFS channels and even with the more spectrum that FCC has identified to make available to us, and that's something we talked about in the last webinar, you still have to try to get the most out of the spectrum that's available. It is the most precious resource for sure. So this one here is where we're going to do band balancing. Of course, we still recommend that you deploy 2.4 pervasively. We're not, of course, it's a 5 gig. These days, everyone's using 5 gig more and more, and most clients out there are going to support 5 gig. There are some stragglers, some clients still that are 2.4 only. But we're recommending that you do deploy 2.4 pervasively, so that you're not just going to have 5 gig in some areas of your deployment. But we do recommend, of course, spectrum load balancing or band steering. And with our system, anyways, you can have a threshold. So you can say basically, okay, we want the number of clients to be, greater than 10 or 20 or whatever. We have the ability to configure the delta between the two bands, so you can customize your band steering or band balancing, and that's what we're showing here. Okay, one of the things we should talk about, and this is really important, is as far as signal strength requirements. It was pretty straightforward back with 11N, but now with 11AC Wave 1 and Wave 2, with the wider channels and with the higher modulation schemes, the 256 QAM versus 64 QAM, most of you would know that 256 QAM it came with 11AC Wave 1, and of course Wave 2 supports 256 QAM. And as you have higher modulation schemes or denser modulation schemes, it requires a higher SNR because the symbols are going to be closer to one another, and they're basically more susceptible to noise. We need a higher SNR to be able to support those higher modulation schemes. In fact, when we did rate and range testing, and this is competitive rate and range testing, we saw that we could only support 256 QAM clear line of sight to about 25 feet. Beyond that, we would not be able to support 256 QAM. It would go down to MCS 7 and so on, which would be 64 QAM. And so we put this table here just so you have an idea. If you can see that as you get wider channels, for given MCS, the signal strength requirement goes up to the point where if you were to go up to 160 megahertz and you're trying to support 256 QAM NCS 9, you're looking at a neg 49. So if you're designing your network with 160 megahertz pervasively, which we're not recommending because there's not enough spectrum for one thing, but you're looking at having APs that are 35, 40 feet apart from each other or something like that. It would be pretty expensive to do that. Now, could you do that? Could you, have a network where you do 80 megahertz? Yeah, and then you would need make 52. Now, so the APs are, pretty close to each other. Instead of having them at, 80, 90 feet apart, they're probably more like 50 feet apart or something like that. Just something that you have to consider. And we have some slides that illustrate that a little bit later coming up here. So let's see. So this is just making that point that if you're trying to support 256 QAM, you can look at the size of the coverage area relative to 64 QAM. So it's a much smaller cell size where you're going to be able to support 256 QAM. And for those of you that aren't really familiar with why that is, we did have a webinar series that I believe is still available, and it should be. And basically, it's an older webinar series. We did it in 2014, but it's a 6-part series, and part 2 goes into the 11AC featured deep dive, and then it goes into 256 QAM and multi-user MIMO and beamforming and aggregation and all the fundamentals of 11AC. Okay, so just to illustrate the point here, if you had this building and you had 6 APs and you were designing it for 64 QAM coverage everywhere, you could do that with 6 APs as illustrated here. Now, if you were to swap out, if you do a 1-for-1 replacement, and a lot of times that's what we're recommending if you currently have an 11N network or you're going to be doing an 11AC upgrade, and there's currently an 11N network installed. If the 11N network was designed for 5 gigahertz and it was designed for 64 QAM coverage everywhere with 5 gigahertz, then if you were to do a 1-for-1 replacement, you'd get the same type of coverage, basically, more or less, with 11AC 1-for-1 replacement. Now, if you're hoping to be able to support 256 QAM with that 1-to-1 replacement, then that you're not going to get that. What you see here in the white space would be all the areas where it would be very unlikely and that you would be able to support 256 QAM. In fact, these cells are probably a little bit generous because it's not clear line of sight. This is idealized. Of course, it's not really like that in the real world. But this is just to illustrate the point that you have a lot of areas where you would not be able to support 256 QAM, which would be okay. You wouldn't be getting the benefits, one of the the benefits of 11AC, but it's that's what brings me to the point, or back to the point where I was making, where you get your most bang for your buck with 80 megahertz, right? Because 256 QAM is a nice feature of 11AC, but you're not going to get it everywhere if you can't rely on it everywhere if you just do a 1-for-1 replacement. Alternatively, you could add more APs. Now that's obviously going to raise the the cost of the deployment. We're not recommending you do this necessarily, but if you absolutely need to get the most out of 11AC, well, one of the ways that you're going to get the most out of 11AC is by being able to support 256 QAM everywhere, and that would mean you'd need to add more APs, but that would be expensive, and so and unless you absolutely need to eke out every little bit of capacity of 11AC, we're not recommending that you actually do this. And it would only be helpful if you have enough channels available, right? So if you look at the number of APs here, what do we have? We have, what is it, 10 APs? 10 APs, so if you're using 80 megahertz channels, and we would recommend 80 megahertz channels, again, if you have DFS channels available, you would need, 10 non-overlapping channels. And in the US, there are only 6 non-overlapping. And so, yes, you could have the APs that are at the opposite ends of the buildings on the same channel, or reuse those channels with probably not too much CCI. But you just can't keep adding APs without having to reuse channels, and then that gets counterproductive when the APs that are using the same channel within hearing distance of each other, because then they're going to create CCI, and they're going to have to defer or share a channel, like what we talked about with staggering channels. Share an 80 megahertz channel, for instance. Okay, so this is just, again, making the point that if you want to support 256 QAM everywhere, you'd have to put the APs considerably closer together, and again, raising the cost of your deployment. So not necessarily not a recommendation unless, again, you absolutely need it. And there are, by the way, I have worked where every bit of capacity is absolutely required. Like for instance, a trading floor, right? Where you'll use every channel that you can possibly use because you want the maximum amount of capacity, something like that. And so, yeah, there are times when you try to get the most, possible out of Wi-Fi in terms of capacity, but they're not that common. Oh, AP transit power. So yeah, you can have your APs use auto power, or you can manually configure the power. In some cases where if you're doing a static deployment, and by the way, there are a lot of places where static deployments make sense. That is to say, static channel plan and static power plan. Like for instance, in arenas and stadiums, you'll see deployments where everything is just statically configured. We're not relying on auto power, auto channel to do that for us. So we just statically configure it. And so another way of shrinking the cells, obviously, is by reducing the AP transmit power. And we have some guidance later on in the summary of wireless LAN recommendations. We have some guidelines for power settings, min, max, both for like high density auditorium areas and classrooms, for instance. And here, by the way, there's going to be a few slides here that they're tables. We're not going to go through all the tables because they are actually taken from the deployment guide. I just wanted you to know that in the deployment guide, at the end of every section, there's a list of tables and the best practice recommendations. So you don't actually have to read the guide. You can go right to it and use it as a reference to just know what we're recommending. We say what the default values are basically, and then the recommended values. So you can just use it as a quick reference guide. Let's see. Yeah. So like for instance, spectrum load balancing, it would depend on the model AP because the ratio of 2.4 to 5 gigahertz clients, really it depends. So as the AP becomes more powerful, the settings, the thresholds go up. Like for instance, the default threshold for C120, and for that matter, all of the APs for spectrum load balancing, band balancing, would be 10. But as you see, the C120, we set that to 40. So we have those kind of recommendations in the guide. Let's see. The min unicast, min broadcast, multicast, and management data rate are also set to 24 megabits. Let's see. You see here we have, for fast roaming, we're recommending that you turn on 11R. By the way, with Mojo, with the 11R, so a lot of people are worried about turning 11R or fast roaming on because they had clients that don't support it. But with our system, you can do the mixed mode support. So that means that if there are clients in your community and on your network that don't support 11R, not a problem. They're going to be able to associate. They won't be required to use fast roaming, so not a problem there. Let's see. I won't go through all of these, but you see proxy op and minute association rate. So we won't let clients associate unless they're at least neg 65, for instance. I'm recommending that you turn on Bonjour Gateway. In a lot of campus environments, you're going to have Bonjour services and Apple devices and so on. So we're recommending that's enabled. Let's see. Another one I'd like to point out. Yeah, reliable multicast delivery. A lot of campuses, of course, they'll have video brought in from satellite or from cable, and then they'll have like a V-brick or a high vision or some other way to put that. Basically support TV over IP, IPTV, and they'll put the channels, or they'll publish the channels, and those channels, that those streams for the individual channels will be multicast on the wire, and then we're going to want to get that multicast traffic and went to the AP, and then once it gets to the AP, we will then convert it to unicast and then transmit it as unicast to the individual clients, Wi-Fi clients that have subscribed or tuned in to that particular channel. And so you want to enable that most likely in campus environments. And ABC, ABC, I haven't talked about it very much, but that's something that you want to turn on because not all traffic is going to get tagged appropriately at the source. And like for instance, if you have that multicast traffic, it may not be tagged as video over the when it's transported over the switching network. It may be. It depends on the switching infrastructure and the video source and so on. But you want to also enable ABC at the access point so that in the event that it's not tagged as video, the access point can identify it as video and then use the appropriate queue as it transmits the traffic to the client. So it uses the video queue, excuse me, so that the traffic takes priority, video traffic takes priority over the best effort traffic, data traffic, or the background traffic. So you'll want to turn that on as well. And let's see, tunneling. That's a feature where you would basically tunnel guest traffic so that it would be tunneled. It wouldn't go over the main, VLANs. It would go over a tunnel to the DMZ for all of your guest traffic in the campus. All right. Now we'll jump on to LAN deployment best practices. I'm just going to highlight a few things here. We do have a table or a few tables that will summarize it all. But for switching, this is one that most people know. With 11AC, you really want to make sure that you're a gig to your access point, and that's probably not going to be a problem. Most access switches are going to be a gig these days, if not all of them. But then also you want to make sure that your uplink to your core switch is a minimum of 10 gig. And because you wouldn't want that to be a bottleneck. So from your access switch to your distribution or to your core, you want to make sure that's 10 gig. And ideally, you want to multi-home that, right? So you probably want to have, if your access switch going to your distribution switch, two different distribution switches, each 10 gig each. So that way you have some fault tolerance there. Okay, let's see, cabling. Just put this as a reference for cabling. And we know that there are a lot of Cat 5e infrastructure or cable plants out there still today. If you're and you can run 11AC on Cat 5e. For sure, I've done it, and I've done pretty long runs. We had a 20,000 square foot facility that we used to do competitive performance testing, and some of the cable runs were actually beyond 50 meters. We know that, but it was mostly all Cat 5e. And we really didn't see a problem, but the guidelines are, for Cat 5e, if you want to support 1 gig, it's rated up to like 50 meters. So if it's going to be a new cable plant, then we recommend, Cat 6e or greater, and for wave 1, and 6A for, or to 7 for wave 2 APs. We say that because you could get, more than a gig on a wave 2 AP. There are use cases where you could oversubscribe. Basically, and if we had a multi-gig interface, then you could get beyond a gig in certain scenarios. So that's something that keep in mind. Okay, power requirements. Most wave 2 APs are going to require PoE plus, and I can tell you that the C120 will. It doesn't. It actually it's fully functional with PoE plus or AT 802.3 AT. It will operate with AF power with reduced functionality. For instance, the USB port will not be active. The second Ethernet port will be disabled, and it will be I believe it's a single single spatial stream on 2.4, and that two spatial streams on the 5 gig side. So you would have both radios, and it would still work. It would be reduced functionality. So we do recommend opting for AT power or PoE plus for the C120, and for that matter, that's true for other Wave 2 APs in general. That's true as well. All right, LAN PoE. This is just a table we put up there. It's in the guide again for reference for the different model of 11 AC access points that we have at Mojo Networks, and then a description of the capabilities and so on, and then recommended use case. The C120 would be recommended for high density, high throughput areas. Again, and with it also has the PoE requirements there, but will function again with reduced functionality if it's using AF power. Which is, our other, I should point out that our other AP, like our C65, which is the 2 spatial stream, C75, 3 spatial stream, Wave 1 APs, they're fully functional with just AF power, as is the W68 will completely be functional in terms of the radios will operate, and the ports will be, all ports will be available. However, with the W68, which is the wall plate, which is really well suited for dorm rooms or hotel rooms, it actually has PoE out. That is on the ports. It's 4 ports out, but that would be only if it's operating powered on PoE plus. If it's powered on PoE, you wouldn't get the PoE out. And then we have the 090, which is an outdoor AP, and it requires PoE plus. Now, as far as LAN, we know that there are lots of different architectures out there, and you'll see anything from a campus with a /16, big giant flat network, and then you'll see where we have some schools where we have multiple VLANs per building, or other schools where we'll see 1 VLAN per building, and that's 1 VLAN for user traffic. They may have another VLAN for management, network management purposes. But here's what we're recommending. Now, most schools are not going to change their VLAN because wireless WAN or network vendors suggesting, it is what it is. But if it's a new design, we think that this type of design is reasonable, where you actually do have a single VLAN for user traffic for an SSID, like SSID1, VLAN 1, for instance. So we're not, and rather than have big giant flat network. Now, big giant flat network has some advantages, but of course it has disadvantages. So we think that this is a reasonable kind of trade-off, where you have a separate VLAN for a building for an SSID. And there are some advantages there. For instance, almost all competitors, and we certainly have multicast and broadcast filtering capabilities, so we can deal with the larger VLANs. There are ways to do that, but we're recommending more of this type of VLAN architecture. So in summary, the best practices here, I won't talk about too much other than to say, talk about QoS. We want to make sure that we have QoS end to end. Ideally, you don't want to just rely on your access points to do QoS. You want your switches, or you want some type of ABC solution, application visibility and control solution, at the egress, right, as traffic comes in from the internet, because we want to make sure that traffic comes in from the internet, which with best effort, we want to make sure that if it is voice or video, we want to make sure we identify it as voice and video and tag it and prioritize it as soon as possible, as soon as it hits our network. If in the event it doesn't get tagged and it goes as best effort, the video traffic or the voice traffic goes as best effort through the switching infrastructure, the APs we'll certainly have ABC turned on the APs so that they can identify the traffic, and at least on the down, as they go downstream, or as the APs transmitting the traffic over the air to the client, it's being put in the right queue. And it really does matter. I mean, if you don't have QoS turned on and you have an AP that has a combination of voice, video, and data, and you're trying to look at if you were to measure the MOS or the media delivery index, the quality of the video, where you're looking at loss rate and delay factor, or MOS for voice, mean opinion score for voice. You're looking at delay, jitter, and late retry rate and loss and all that. If you do testing and you have all that traffic at best effort, and then you do some testing where you're actually tagging the video appropriately and the voice appropriately, you're going to see a huge difference in the quality of the voice and the video. So it really does matter. Most of you probably know that, but for those that haven't experienced it, I'm trying to basically help you appreciate the value of enabling QoS. Okay, just quickly for AP channel deployment best practices. We talked about this last time. Mojo Planner, it's freely available to our customers and partners, and it's easy to use Mojo Planner. It's full featured, but we really tried to streamline the workflow so that there doesn't really take any training to get to use it to already do your planning. And of course, it looks at it looks at the type of applications that you're running, the number of devices that you're going to have, the types of devices that you're going to have in your environment, and it factors all that in to give you a predictive or plan. So as a starting point, to give you an idea of how many APs you're going to need and where you can put the APs, and of course, it is something that is a starting point. You do the deployment, and then you monitor, measure, you get all kinds of metrics, and then you can add APs or adjust as needed. And we'll talk about that adjustment part, monitoring and adjustment part more, of course, in the next session. Now, here's just a simple 40 megahertz channel plan. I'm going to put that up again. What we tried to do there is using 40 megahertz. You'll notice that there are no DFS channels being used. We're just using the same 4 40 megahertz non-overlapping channels, and we use them again and again, and we try to just give you an idea of a good channel plan. Now, I can tell you all the years that I've been testing competitors' auto channel, whether it's I won't mention any names, but you know the names from the competitors. They have their own unique ways of describing auto channel or labeling auto channel. I've never seen one come up with a channel plan like that. It seems like they struggle. I've seen it where, basically you'll see channel 36 and 36 right next to each other, adjacent to one another. And I'm talking about when all 4 channels are free, right? We're not talking about where there's a lot of interference or, Wi-Fi or non-Wi-Fi on the channel. It's kind of mind-boggling that sometimes the channel plans that are, that are chosen, or you end up with channel plans that are just seem like, wow, why would they do that? That's going to definitely not be good for performance. Not to knock all, auto channel in general, it definitely serves a purpose, but you just have to be careful because not all configurations or channel plans that those algorithms end up with are optimal. And here's one for 80 megahertz channel plan. This is where we can use DFS. And so the E stands for like extended. So that would be 36, 40, 44, and 48, and so on. And so here's where we're using the 6 non-overlapping 80 megahertz channels that are available in the US. Now, of course, if you can't use all 6 80 megahertz channels because you're getting a DFS event on one or more of the channels, then you can remove that channel from the candidate list, and then you could build your 80 megahertz network using 5 non-overlapping 80 megahertz channels instead of 6. Here, we kind of, I personally, I'm going to say I would recommend using Echo Site Survey. I know there are other tools out there, but I think this one is probably the best, and definitely I would say probably the most popular too, at least here in the US, and I would venture to say elsewhere as well around the globe. It's full featured. We recommend using the hybrid mode, which is a combination of passive and active. Passive is not looking at packet transfer, but active is actually looking at the packet sent and received. so we can get more information, more detailed information about coverage, signal strength, and all. And recommend you survey both 2.4 and 5 gigs, and disable auto channel, of course, and remove all SSIDs from the client supplicant, so you're not jumping around from one SSID to another while you're doing the survey. And you want to gather, sufficient number of data points. So this is and you want to do the survey preferably with the doors closed and so on, because that would be like kind of the worst case scenario. In one regard, anyways. It could be the best case scenario if you're trying to avoid CCI, but if you're trying to see, how coverage can be impacted by having more attenuation, then you close the doors. So we put this together or had these recommendations because it's super critical, obviously, that you do a post-deployment site survey, a thorough, comprehensive. That way you can find out any places where the network needs to be optimized, either power adjusted, channel plan changed, or more APs added. Okay, just quickly going to go through a quick little deployment kind of scenario with a dorm room. So this is a wing of a dorm, and the attenuation is moderate to high between the dorm rooms. And so we're going to recommend that you actually put the APs in the dorm rooms. We had a lot of experience with this over the years, putting the APs in the hallways. And we found that with the high attenuation of some of these the building materials used, the 5 gigahertz didn't get really, it wasn't good coverage in some of the rooms, some parts of the rooms. And so now we're recommending that you put the APs actually in the dorm rooms. So this is a heck of a busy channel plan, right? But in this case, we're using 40 megahertz. We're not using DFS channels. For instance, we're saying that DFS channels are not available in this particular, or there's some reason that we don't want to use DFS channels. We're not sure if all the clients support DFS channels and so on. So we're using non-DFS channels, 40 megahertz plan. We're going to use the W68 for this, and that's that wall plate AP I was mentioning. So we'll put one of them in each room, dorm room. And now so this is the 5 gigahertz channel plan. Yes, we have to reuse channels because we only have I'm mistaken. We are using DFS channels, but not all of them. Let's see. Yeah, it's 40 megahertz, and we are using some DFS channels, but we're not using all the DFS channels. Some of them are just unavailable. I stand corrected. So, anyways, we have to reuse the channels because we only have 1, 2, 3, 4, 5, 6 DFS channels to work with. And again, 40 megahertz channels. Now, if we look at the 2.4, you'll see that, we kind of illustrated that these circles are bigger, meaning that the 2.4 is going to basically propagate further with good signal strength. And that's what it does naturally, and because of the longer wavelength. And we're going to see that now we're able to basically have a 2.4 for every other room or so. And that means that we're not, we're just basically disabling the 2.4 gig radio in every other room. So we do this because we only have 3 channels to work with, non-overlapping in the US. And we don't want to we don't want to create CCI, co-channel interference. We don't want to have self-induced CCI, because having 2 APs, in the same area on the same channel, it's not going to double throughput capacity. It won't double throughput capacity. We all know that. There would be the only exception of having why you'd want 2 APs in the same area, like on channel 1, for instance, is maybe even having, say, 6 APs in an auditorium where you have 2 APs on channel 1, 2 APs on channel 6, and 2 APs on channel 11. Yeah, there are times you'd want to do that, but those are fewer and fewer out there in the real world, because in the old days, when you didn't have clients that support 5 gig, you just needed enough radios to support all of your clients to associate. And if they were mostly 2.4 and you had hundreds of clients in a small area that were 2.4, you had no choice but to deploy multiple radios on the same channel. Now, it wouldn't add throughput capacity, obviously, but it would add association capacity. And so there are exceptions where you'd want to have, I just want to point that out, where you would have two radios on the same channel in 2.4, for instance. So we just really to support the number of associations. But again, that's rare these days because most clients are dual band, so usually don't have to do that anymore. All right, let's see. Yeah, all right. AD placement best practices. So yeah, so I won't go through all of these, but I guess I should talk about the consider one-for-one replacement. We talked about that a little bit, and only if the conditions are true. And the conditions that I'm referring to there, that's in the guide, and I didn't put them all in here. But basically, it asks a number of questions like, was the network designed for 5 gigahertz? Was the network designed for support voice and video everywhere? And so on, and you can find those in the guide. And if those conditions are true, then you can safely do a AP one-for-one replacement. So swap out your 11N, put it in your 11AC. SNR, throughout the deployment, signal to noise ratio 25 dB or greater, and min RSI. We used to design for neg 65, right? And that was kind of common for a long time to support voice. That is. Neg 70, 72 if you didn't really have to support voice everywhere. But now we're saying neg 62. And that's basically because with wider channels, when you use 80 megahertz channels, your SNR requirements are higher. So even if you're not designing for 256 QAM everywhere, if you're designing for 64 QAM everywhere, you still want to go stronger. You want to go to better signal everywhere to support the wider channels. All right, I won't go through all of these, but here's the power. This is one I wanted to mention. So we do have some guidance in terms of if you're designing for a classroom, your min power, the range should be somewhere between 8 and 16 dBm, and 2.44, 10 dBm, and then for lecture halls, it's even lower. So we put those there to just give you some guidelines, so where to start. And so you don't want to start at high power, obviously, because your cells will be too large, and you'll limit your ability to reuse channels. All right, let's see. And we talked about 2.4 already, as far as strategy for deploying. And a little bit more here about antennas. And just basically, we have some guidance in terms of, for instance, don't put your antennas too close to lighting fixtures and conductive material. This is all boilerplate type stuff, and some of you know this by heart. But we put it in the guide for those that may be new to wireless LAN design and deployment best practices. Finally, we're going to get to just as far as network services. Now, our APs, because they're controllerless, cloud managed controllerless APs, they pretty much have a lot of these features built in, right? But for campus deployments, we're not recommending you turn on the DHCP server in the AP, or turning on the firewall that's built into the AP, because those features are really for remote locations, one AP locations where they don't have all those services. Then you can turn the services that are in the AP. But for campus deployments, we're recommending you use the campus DHCP servers and the campus DNS servers and so on. And of course, for a campus firewall, we're recommending that you use the campus firewall. You don't use the firewall built into the AP, and we put the ports there you want to add the rules for. NAT, same thing. Use the campus NAT. The AP can do NAT, but you don't want to do that for a campus deployment. AVC, the AP can do AVC, but also, that's out at the edge, the access, right? You want to do AVC as close to the server, the services, or to the internet as possible. That way, the traffic gets tagged at that end of the network, so that when the traffic goes to voice or video traffic or whatever traffic goes through the network, it's going through the switching infrastructure with the proper priority. So that's part of the whole cross end-to-end strategy, right? Okay. Let's see, content filtering. Again, you want to use the campus, and Radius, of course, the campus solution as well. And now we turn it over to Q&A. All right, and wow, it's already 9:52, so I'm going to go fast here. I got some questions that came in. The first one is, do you recommend removing support for any 11AC MCS rates? Yeah, that's a good question. So 11AC MCS rates, the only two that are optional with 11AC are the higher rates. It's kind of interesting. Usually you want to remove the lower rates. But with 11AC, you have the option of removing MCS 8 and MCS 9, and those both require the QAM 256. And you say, well, why would I want to do that? Well, if you have a really noisy environment, a very high density noisy environment, the chances of benefiting and being able to use 256 QAM are pretty low, right? Because you need high SNR, signal to noise ratio, if you're going to support 256 QAM. So why waste the time and the air time, and why clutter the air with all these attempts to use the higher modulation schemes? Because most clients are going to try to use the higher modulation schemes, especially if they're relatively close to the AP. Why do that? Because then you're just wasting airtime, because they're not going to be successful. So the clients and the AP they're going to have to rate adapt down. So just spare everybody and make better use of the airtime by removing support for MCS 8 and MCS 9. That way you don't have to waste time and so on. So that's one strategy. Are 2 Ethernet cables needed for the Wave 2 APs? Well, potentially yes. If you have the rare occasion to use a 160 megahertz channel, you could potentially oversubscribe 1 gig link. So like the C120 has the ability to support 2 Ethernet cables, and you could use link aggregation, bond those two, so you can effectively create a 2 megabit per second pipe. And so if there are, if you have a location, say you have a remote location, maybe a portable or something like that, that's a standalone kind of situation, and you have a high throughput requirement there, you could put a 120 in there with a 160 megahertz. Again, that's when you don't have to worry about co-channel interference. You have the whole, the spectrums available. The 160 megahertz is clean. You could potentially use the 160 there, and you could potentially oversubscribe with the combination of the 160 and the 2.4. Both radios operating concurrently. There's potential to subscribe a 1 gigabit per second link. Okay, can you elaborate on your ABC recommendations? Yeah, I touched on this or talked about this somewhat. Like a classic use case for having an ABC turned on, having ABC capability either in your switches or a standalone device appliance at your as you get traffic coming in from the internet, is because the traffic from the internet will come in as best effort, whether it's voice, video, whatever. And maybe you want to prioritize that. Most likely you would want to prioritize that as soon as possible, so that it goes through the switching infrastructure as voice and takes priority over best effort traffic and so on. So you'd want to do ABC in your data center and close to your servers or services, your voice, video, and so on, and your internet entry. And then you also want to do it at the AP. You want to do it at both ends so that it's an end-to-end cost solution. Can we run 11AC APs on Cat 5e? Yeah, you can. I certainly have, and I have honestly. I can't say for sure the longest cable run that I had. I don't know. I didn't measure it, but I do know that I was running doing a lot of competitive performance testing on Cat 5e runs that were, I would say, safe to say, over 50 meters, and we didn't see a performance hit. But the general recommendation is to go with Cat 6 or 6A for new cable plants, or even 7. Does the C120 require PoE plus? Again, oh yeah, so it doesn't require it. You can run it with AF power PoE, standard PoE, but you, again, would be running with reduced functionality. So as a stopgap measure, if you wanted to put 120s in and you have an AF plant, a PoE, just standard PoE, you can do that. But the recommendation is to upgrade to PoE plus or 802.3 AT. Okay, so let's see. I guess that's it for questions now. So I'm going to turn it back over to Erica, and we'll. If there are any more questions, you can send them along and I'll respond. But now I'll turn it back over to Erica.